You can proceed now.
Hi, Krish. A very warm good afternoon to one and all who present here. I am Purna Chandru. First, I heartily welcome our beloved principal, Dr. C.T. Jayadeva sir, to this session. Welcome to the session, sir. Now I heartily welcome our beloved HOD, Dr. G.M. Satyanarayana sir, to the session. Welcome to the session, sir.
Thank you.
Now I heartily welcome Naveen sir, today's speaker, to this session. Welcome to the session, sir.
Thank you.
And welcome you by the side of College Adichunchanagiri Institute of Technology and by the side of Tech with Mech. Welcome you once again, sir. Finally, I welcome all the faculty members and participants who are joining in this session. Welcome you all to this session. Let us not waste the time and request our HOD sir to speak some words about this occasion.
Hello, good afternoon, everybody.
Good afternoon, sir.
My dear student friends, and today's speaker, Mr. Naveen, and my faculty staff, faculty members of the department. Mission tool play a vital role in enabling manufacturing companies in industries to deliver components and products to the highest specification. They provide the basis for precision manufacturing. Now, regarding this particular topic, development of mission tool and operational properties. Now, the knowledge of this mission tool and its operational properties and activities, now it's very, very essential for the budding engineers, especially the mechanical engineers. Okay, on this today's, in this context, I welcome Mr. Naveen or Karki, Managing Director, Naveen Engineering Services, Hubli. Welcome,
Thank you, sir.
I request the speaker Naveen to go ahead with his topic, webinar topic, development of mission tools and operational properties. At the same time, I'd like to thank our department coordinator, Mr. Professor Vilas Vative. Thank you, Vilas. I request Naveen, please go ahead.
Thank you, sir. Okay, sir. Thank you. Thanks for your permission. Thank you. Rashid, can I start now?
Yes, sir. You can start. You can proceed.
1 second. Rashid, 1 second.
Sir. Okay, sir.
Hello, Naveen. Hello. Rakshit.
Yes, sir.
No, actually, I forget to thank Rakshit, the coordinator of Tech with Mech, and his teammate. Okay, I welcome you to this webinar, and I would like to thank Rakshit and his team members. Thank you. Please go ahead, sir. Naveen, sir.
Now you can hear me. Okay, thank you. Can you see my PPT? Rashid?
Yes, sir. Yes, sir. Go ahead, sir.
Yeah, good afternoon, everyone. Today's topic is the development of machine tools, design and operational properties. Okay. In this webinar, I want to take one small case study which was already developed in my industry. Okay. Everyone knows about what is the development of machine tools, design and operation property. Okay. Design is an entirely different concept. Operation properties is an entirely different concept, and machine tool is an entirely different concept. Clear? Hello. Hello.
Sir. No interaction, sir.
Okay, sure. Thank you. The second slides, I'm going to take a study of a design and manufacturing plastic injection mold for base cover of bus ticketing machine, right? All of you have seen base ticket machining. Hope you remember this one, right? Before in the KSRTs or any private government or non-private buses, the conductor will going to issue this ticket, right? Instead of this one, we developed this one a base cover. We call it as a base cover. Okay. For this base cover, what are the tools are required? What are the properties should be considered being a mechanical engineer one, and what are the machines to be considered to develop this product? Okay. So this product is developed for XYZ company. I don't want to reveal the company name. Okay. So this is the base cover we have already manufactured and delivered to the end client. Okay. The third is integration of understand the product. See, when a client given a product for you, right, you have to understand what type of product is there, what type of material should be used, what type of the machine should be considered, and what type of the tools should be considered, right? This is the front view and side view and top view of an understanding the product. This is a client product. Okay. Once you go through this client product and draw the 2D and 3D, then you have to understand the statement of the problem. What is the statement of the problem? See, the client will give the different statements for the problem, right? My client given the design and manufacture of single cavity mold for the component of base cover using the concurrent engineering. Okay. In engineering, there are two types are there. One is the traditional engineering and another one is concurrent engineering. In traditional engineering, there is a barrier between the one department to the another department. Whereas in concurrent engineering, there is no barriers that we can, it is worked as a teamwork, okay, that we call a concurrent engineering, right? For using this concurrent engineering, the client given for us to develop the ABS metal. All of you know what is the ABS metal. There are so many plastic metals are there. PLA is there, okay, size, nylon is there, ABS is there, PPL is there. So many plastic components are there. In this case study, we taken this ABS metal, okay. Now, what is ABS? What are the features of ABS? I'm going to show now. Okay. Before that, going to manufacture any product, you have to understand what is the geometry of the component. See, every individual component is a different virtuality. Okay. To achieve the correct geometry, we need to follow guidelines. One is the design consideration. Okay. You have to understand what are the numbers of cavities are there. Whether it is single cavity, 2 cavity, 6 cavity, 4, 24, there and up to 38 cavities we can manufacture. Okay. The second thing to understand what is a straight parting surface. Okay. Next, what type of pin injection should be used. Okay. And fourth one is molding machines available. See, there are a lot of machines available in the industry. Maybe it is in a traditional way or non-traditional, non-concurrent engineering. Okay. In traditional engineering, maybe you have seen that lathe machine, drilling machine, right? Parting machines, all this. But now technology has been entirely changed. Now it is the CNCs are there. Maybe 2-axis CNC, 4-axis, 5-axis, 8, 12, 15-axis. This is all available there. Okay. Once the availability of machines are considered, then you go for the design and fabrication of the tool. Then after the design and fabrication of the tool, you have to consider what quality assessment of the tool should be taken care. Okay. See, being an engineer, any mechanical engineer, you should understand what is the geometry of the component, right? See, any product, any component, you should understand the geometry of the product, right? For this, in my case, I have taken the plastic injection mold, right? In this plastic injection mold tool, I'm considered design consideration. One is the numbers of cavity. What is the numbers of cavities there? Second, straight partnering surface, and third, pin injection, molding machines, and fifth, design and fabrication of the tool, and quality assessment of the tool. Okay, once you consider all these parameters, then we have to consider this next step. The next slide is about the design objectives. See, in the industry, when you take any client requirement, there are the three important things you should understand. You have to know about is what type of tool you have to use it in the industry. Second, what type of machine you are using to in the industry. Next, what are the availabilities is available in your premises, means in your industry. This is the most important things you have to keep it in mind. Being a mechanical engineer, see, any object, any plastic injection mold, right? Any components related to plastic injection mold, right? Design objectives. First one is the design tool as simple as possible. Okay. Design for the machinability, that is reduce the manufacturing lead time. See, lead time is nothing but a duration of the manufacturing the product and delivering the product. How much you reduce the lead time, that is benefit for your organization and for your client also, right? Next, you have to understand what is ABS, right? You should understand the physical property, you should understand the mechanical property, and you should understand what are the characters which will be molded in the molding process, right? After that, you have to design for the product to achieve the component performance, right? These are the four important things you should consider in the product designing, right? Any new product development, maybe it's a new one, or maybe it's the old one, maybe you want to do the re-engineering, you have to consider all these parameters for the plastic injection molds only. Okay, for different tools, the press tool, we have different, the design structure, tools are different, everything is different. But in my case study, I'm taking plastic injection mold, right? So after this design object is the scope of the work, right? So we are doing one product, what is the scope of this project, right? Or component. So first, analysis of component geometry, which enables the choice of partnering surface. What is the feeding, injection location, where should be injection location be located? Might be you have seen in the foundry, you are using runner and riser, right? Where you are locating the runner and riser. Same here, we are locating the injection pins or feedings and injection techniques. What are injection techniques are there? Next, after that, you have to consider what is the design of injections, mold, and tools. Okay, and after that, you have to study the physical component of any property. So, take an example like if you want to buy one iPhone mobile or any Samsung mobile, you see the features of those mobiles, right? Why you're saying? Because what is the features? Any new features are available? Whether your feature is cope up with your working the technology and all this, right? The same manner you should be considered here in the selection of material. You should understand what is the physical characters of the material, what is the mechanical property and process properties of the tooling material, and its influence with the molding material. And finally, after doing all these first, second, third parameters, finally you have to find out the try out of the tool and correction of molding defects. What is a tryout? Maybe the word is unique for you, but in the industry we are saying the tryout. Tryout means trial and error of any product, right? Maybe you take any product, you have to check the parameters whether it is matching with the drawing or not, and everything. That for that reason we are trying this try out, nothing but to find out the whether it is the drawing is matching with the tool or not, right? And if you are not matching, so there is some corrections you have to do in the molding defects. This is we call a tryout. Okay. So after this scope of work, then you have to go, what is the metal you are going to select? In this case today, I have selected ABS. Why I selected ABS? Because the low density compared to the steel, second, good surface appearance, aesthetic look is very good, good resistance to the observation, resistance to the flexural fatigue, and good aesthetic and good ergonomics designs and ease of manufacturing. Okay. See, depends upon the client requirement. You can take as a PLA also. Okay, ABC also, any plastic materials also. Okay, in this case study, the client requirement is ABC. Okay, ABS. So ABS is nothing but a low density compared to the steel. One thing, good in the appearance and good aesthetic look and good ergonomic design and ease of manufacturing. So after the selection of this material, then you have to go for the properties of an ABS. Why ABS is so unique in this product. See, the main uses of ABS is cabinet for the office machine, okay, televisions, radios, loudspeakers, telephones, computers, toys, and inner liners for the refrigerators, and cabinets for kitchen machines, pipes, automotive parts, so many, etc. Where you can, where the inside material will be using, all the components are like nothing but an ABS material, okay. The electrical resistance, okay, attractive glassy surface. For outdoor application, it is necessary to use whether the product and the adhesive, that is example using the carbon black to prevent UV radiations, okay. Once I select all these parameters, then you have to go for the, what is the standard. See, I mentioned here is 81300T AMI. This is the standard of the European standards for 2012, okay. And the same thing for 2000T AMI 2011, the plastic European standards. See, you have to, any selection of metal, you have to consider your standards. So, okay, you can't bifurcate from the standards, right? You can't do that one, because whenever you being an engineer, you should follow the standards. Once you follow the standards, you have to implement those standards and implement in your product, okay. So after the consideration of any physical properties of ABS, then you have to understand what tool you are using in this. See, in the mold manufacturing, usually there are 4 types of most important things in the plastic mold. One is the mild steel, we call as ST42. This is the grade, okay. And one is hot die steel, grade is S13, T35CR 5MOV1. See, these all grades are not mentioned in your textbook. First and foremost, the practical thing and the theoretical thing is entirely different. Try to understand, okay. So many guys will understand that, sir, I studied some standard metal, I studied the design engineering aspect. See, practical thing is different, and theory is entirely different. So in practical, we are using mild steel, the grade is 42. Sometimes in your textbook it is mentioned or not, I don't know, but usually you have to follow the standards, okay. Then hot die steels, you have to follow the S13 T35CR 5MOV1, okay. And next you are using for the case hardened steel, that is the 17 MNL CR95. These are the 3 important things should be considered in the manufacturing of the mold, okay. See, the mild steel, why I chosen the mild steel? Why can't I chosen the SS304, 204 metals or EN18 metals, right? See, mild steel is used for manufacturing plates like top plate, bottom plate, ejector plate, core, and cavity also spectrum, okay. For this purpose, I chosen this mild steel, okay. Next, I'm going for the hot die steel. Why I choose S13? Why can't I choose the S11, S13, S15, S19? Why not I chosen? See, depends on your case studies, depends on your product, new product development. You have to find it how much that steel is used for S13. See, S13 used for manufacturing cores and cavity. For especially who are building the cores and cavity, 99% all industry are using S13, that is T35CR5MOV1 grade, okay. After consideration of this odd die steel, next you are going to the case hardening steel. Why case hardening steel? Is it necessary? See, case hardening steel nothing but in hardening the material, okay. For that you have to need 17 MN1CR95. This is a grade. These steels are used for the component requiring the high wear resistance surface coupled with tough cores to resist the shock loads and stand given to things. Might be you have seen any vehicles shock absorbers or any suspension where your hardening steel are used, right? The same purpose here also. See, top and bottom dies are molding to each other. When the load is applied on both the side, it should withstand their loads and strength. For this purpose, we are using the case hardening steel. Okay. After selection of all these tool metals in the manufacturing in the plastic injection mold, then you have to consider cavity layout. So, what is a cavity? First, to understand the cavity. See, in MP1, MP2 subject, there are mentioned the cavity 1, cavity 2, right? Cavity 1, nothing but single cavity means only single component will manufacture per second. 2 cavities, 2 components pieces are manufacturing second. Like that, there are 6 cavities, there are 18 cavity, 28, 27, 25 cavities. There are n numbers of depends on your production capacity. In this case, I am using the single cavity layout. For single cavity layout, what are the parameters I should consider, right? First, general layout of the cavity is the first decided by type of the machine. It is specification used for the production of the parts. Second, partning line should be considered in such a way that molding can be ejected easily once it is molded. The third, the cavity should be replaced in such a way that when they are connected with the screw, the runner and the gate will ensure the uniform filling of the impression. So for that single cavity, these are the most important parameters should be considered in the designing the cavity. Okay. So being a mechanical engineer, you should understand what is a cavity, what is the tool, and what is the machine, right? Once you go through all this process, then your process stands here, methodology. See, we won't call methodology, we call as a route map of a product, right? In industry, we call a route map of a product, but in your term, we call it a methodology. See, what methodology? First, you have to design the components with using the 3D solid modeling. Say, there are so many n numbers of softwares are available here. One is AutoCAD is there, CATA is there, Pro-E, right? CATA V12 is there. Even you can draw it in the solid modeling also, right? After this parameter consideration, what type of the design should be considered in which software you have to coop up. I can't say that you should learn all the software. You can learn one or two. Maybe the AutoCAD is a basic tool, okay, just like an ABC. Maybe you can learn the CATA, quite enough in the industry. Everywhere you go, any industry, normally the client will ask only the CATIA and AutoCAD, only two softwares important. Sometimes they are going to asking for the solid edge, ANSYS, right? All these things depends on your work conditions. So here I am using the solid modeling, okay, by using the CATIA, okay. The next is design tool with proper selection of tooling metal. Whatever tooling metal is selected, already shown in the previous slide. The next is 3D modeling model of the tool. See, once you draw the 2D, you have to convert it into 2D into 3D, where you can analyze very easily what are the components fitting in that parts or not, right? Once the 3D modeling is over, then you go for the fabrication of tool. See, this plays very important role here. See, being an engineer, you should understand what is the fabrication of the tool. What is the difficulty you are facing in the fabrication of the tool, right? After this fabrication of tool, then you go for the analysis of the tool. Then analysis, you have to go for the tool assembly and tryouts, and then go for the manufacturing components, right? See, in a simple way, when you got any order, right? Maybe you're seeing this. That's it. See, when you got
zoom it.
Yeah, can you see now?
A bit.
Now?
Yes, sir, it's clear.
Yeah. See, usually when you take any new order, any new product development, this is the procedure will be followed in the industry, right? So many guys knows what is an order. So when you receive the order from the client, first you have to do the 3D drawing, then for the 2D and 3D. This is the first foremost things. Once you complete the 2D and 3D drawing, then it go to the product 3D building, right? Assembling section, means in the drawing one in the AutoCAD or CATIA software, okay? After the 3D building, it go to the product analysis check. What is the check? See, check is the product analysis check where you can analyze the product view, whether it is the dimensions are correct or not, whether the requirement is according to the client requirement is or not. You can analysis here, right? Once the analysis is done, the product analysis check here. Once it comes to okay, then you go for the product review. See, product review, you start from the order. So what customer client is using, like sometimes the client will say that this is the dimension you should follow, right? This is the tolerance you should follow. So this is the order, right? This order nothing but a client requirement. Once the client requirement is completed with the 2D and 3D, you should check with the 3D building, and after that you have to check the analysis check. Once you check all these four processes, go to the product view. Once the product view is completed, it go from left to right. See, the right side towards your right side is a product drawing revision is there. The left side you have the product review, records are there. See, this is the records where it's matched with the your drawing, and product drawing revision is matched with all these parameters. Once these two product matchings are over, then it's come to the product drawing confirmations. This confirmation department will give the confirmation to the tooling manufacturing department. So where you can purchase the tools, right? Before purchasing, you should know the what is the product drawing confirmation, whether the tolerance, what are the tolerance should be there, what is the dimension of the drawing is there. Why? Then once you complete this product drawing confirmations, come to the tooling. Then the tooling department will goes to the tooling work schedule. This is place very important. See, each and every component is not available in your premises, maybe in your industry. Some components should be outsourced, right? For that, you should know the what is the schedule preparation. See, usually the client duration for developing any new product will be depends only 10 to 15 days. Maximum is 15 days to product to manufacturing the product. Okay, within 15 days you have to manufacture the product and deliver to the client. This is the schedule. That part is taking care of the tool manufacturing department. This tool manufacturing department see the tooling work schedule preparations. What type of the tools I should use, whether it is available in your premises, should I outsource it, when it will come, right? What is the time of feasibility, what is the lead time, everything. Once this the tool schedule is prepared, right, then is go to, one second. Then it is goes to test working schedule. This test working section will be helping out or supporting you for the developing the tool. Once this testing tool work schedule is completed, it is go to the tool processing review. Once the tool processing review is completed, is come to the tool drawing confirmation. So once the tool drawing is confirmed, again we have two divisions. One is the for the external parts ordering, one is the material preparation. So material preparation can be done inside your organization, okay? But whereas external parts or ordering should be done in outsourcing. See, sometimes the tool may not be available near your premises. Sometimes you order in the Bombay, sometimes you order in the Coimbatore. It takes a lot of time. You should understand what is the scheduling time and how much time to take the product to deliver your product in your premises. Once it is confirmed from this, okay, then you go for the material preparations. After that QA check, okay, once you receive here in the internal, same thing it is happen to the external. Once the part is received from the external, you have to check the drawing parts, right? Then you have to check the quality. So after the quality is over, then you go for manufacturing. This is the, we call it a road map, or sometimes we call it a mapping, right? Once the mapping is over, then is go for the next process is manufacturing process of base cover. See, this is exactly what I saying is this is a tool you are used in CATIA, okay, CATIA V12 software. See, here we can clearly understand what are the types of the guide pillars are there, core back plates are there, core housing is there, guide pillar, core inserts, components, cavity, spool bush, locating ring, cavity housing, top plate, and injection plates, everything is here. You can analyze how many components are to be used in this product to manufacturing this product, right? Once this manufacturing process of base cover is over, the drawing is finished, then you have to analyze in the design consideration of injection molded. What are the design considerations? So first is the maximum the functionality, one thing. Second, optimize the material selection. Second, minimize the material use. Next is material properties, feed system, and another is a runner system where you can run the runner and gate will be there. Okay. Once this design consideration for the injection mold is over, then you go for the next stage is mold construction. This is the off section of a mold. Can you see it? Rashid, can you see it?
Yes, sir. It's visible.
Yeah, it is visible, no? This is the off section.
Yes,
See, this one is on a top one, this one is on bottom one, middle your component is there. This is your feeder gate, we call it screw gate, right? This is guide bushes are there. See, this is not mentioned in your test equipment. Try to understand. See, industry practical thing is entirely different from the theory, what I was studying in the theory. See, in so many test books, maybe in MP1, MP2, MP3, these all the things are not mentioned here. But when you come to the practical, you should understand what are the things is there, how things are working with these components, and where these things to be done. See, when you manufacturing this component, this is the core, right, base cover. These are all the components required, right? There are so many components are there. Once you complete all these components, you can ready for the mold. You have to take the off section and you have to understand whether it is matching the pin or not, whether screw is central or not central with the parting or not. Then you have to take care of the core plate, guide pillars, and cavity plate. Okay. Once you complete this, then you go for the tool designing. See, this plays very important role here, right? Tool designing is nothing but what quality of the product is there. I'm taking the ABS. Okay, how much density should I take? Whether 10 grams, 1000 grams, 1100 grams, something maybe 3000 grams, like that. Depends on your capacity. And you should know what is the volume built up is there and mass, right? This plays very important role. See, any product you want to manufacture, any plastic injection mold, this density, volume, and mass plays very important role. Okay. So after the consideration all these three parameters, then you go for the cavity load. In this case study, I've taken only single cavity. Only single cavity means single component per second you are manufacturing. That's it. So two cavities, two components per cavity. Okay, per second. So single cavity. So single cavity, what are the time should be taken for melt of the same temperature? What is the temperature should be taken? Maybe low temperature or high temperature should be considered. Next, flow length, how much the flow should be there for inlet and outlet, distance from one cavity to the another cavity, what is the sufficient time for the large private space for cooling lines. See, cooling, there are n numbers of cooling times are there, lines are there. There are different types of cooling times are there. In this case, I've taken a rectangular cooling time. So why I've taken rectangular cooling lines is because it cools each and every corner of the cavity very sufficiently and reducing the heat frequently at a simultaneously. Means cooling line should be plays very important role in the plastic injection mold. Okay, after this cooling lines, then you have to take the injector pins, right? And we have to take the injection pressure. What is the pressure? Once the cavity is over, then you go for the determination numbers of cavities. Okay. See, this is the outer dimension of components taken into account. If the dimension is 10 by 10, so okay, outer diameter, what is that base curve? Outer diameter maybe 205 mm, for example, right? For that 205 mm, how much I take for the injection mold machine? This is the machine capacity, SP230 tons. Okay, so it depends on your production rates. You can decide what types of machine you want to use it. Okay, in this case study, I am taking injection mold machine is SP230 tons. Okay, and you should understand what is the short weight, clamping force, injection pressure to be considered. Once you consider all this, once you select your machine, then you go for the weight of the components. See, weight of the components, even being an engineer, even an entrepreneur, I'm using some formulas are there. This all mentioned in the SOM, right? So why I'm stressing out the important thing is you have to understand the basic fundamental of each and every subject of the things. It is not like I'm an engineer, I know everything. It is not like that, man. First to understand what is W, what is rho and V, right? You have to understand the formula. Okay, formula, you should don't mug up the formula during your studies. Please write down to understand why I should consider density. What is the density plays role in the weight? Why volume is plays role in the weight? So many students have seen that during the exam time, they mug up the formula, they go on and write the exam and come back. Okay. After 1 year, when I ask the question, what is the weight of the formula, they're not able to answer it. See, mugging is different, understanding the concept is different. So always try to understand the basic concept thoroughly. If I say weight, why density is to be considered in the weight? Why volume is to be considered in the weight? Why this density and volume should be multiplied? See, this plays very important role when you take in any product development in the any product, maybe in the press tool, maybe plastic injection mold, right? Maybe today you can feel that, sir, today I'm an engineer, I can go and work in any industry. If you go work in any industry, you should understand the basic formulas. Okay, once you understand the basic formula, it is easy to develop the product. Otherwise, it's very difficult. You can't go and open your textbook and say what formula I should use this because your lead time is very short. Try to understand. So being an engineer, understand the basic fundamental concept thoroughly. Okay, study the any subject, maybe in the SOM, design, anything, understand basic. Once you understand the what formula you're using, then you have to calculate this. After calculation, you go for the weight of the component. See, any component is related depends on the weight. For example, when you go purchase any vegetable like potato, you will ask only 1 kg of kg. That is weight, right? You're also manufacturing any kind of weight. You have to consider the weight of the component and weight of the component, maybe in the kg, maybe in the centimeter, maybe in the mm. Right. Once you consider this weight component, then next cycle is weight of the graft molding weight. See, molding weight, it depends on the weight of the component into multiplication of the factor. This factor should already standards in the industries, and the weight of the component should be already determined in the previous slide. So you have to multiply those value into the multiplication factor. After this multiplication factor, you come to know what is the mold weighting. That is the unit is G by is grams per cavity. This one, right? Once this parameter is over, then you go for the selection of injection molding machines. See, selection of injection molding methods depends on the first on clamping force. This plays very important because this is the more important virtual role is playing in the functioning. What is the clamping force? What force should be there, and why? What are the forces should be considered in the clamping force? See, you can't assuming that the clamping force to be 250 kilonewton or sometimes 2500 pressure like that. You should understand what is the clamping force. First, understand the clamping force. Once understand the clamping force, then you have to projected area of the molding. See, any projected area of molding, you have to take the runner area as a 5% reduction. This is very important. This not be taught in your subject, but when you come to the industry, this is the standard things. You have to keep it in mind that the 5% of runner area should be multiplied with the projection area of the component. Then you will get a centimeter. Then you come to know what is the number of the cavity. So this is a single cavity. So whatever the single cavity you have decided, the formula is given the answer. Simple formula is x is equal to 0 in the theory, but in practical you should do it, right? After completing the clamping force, then you go for the shoot capacity. The shoot capacity depends on the clamping force. The actual shoot capacity, this is the formula you're using in the industry, any industry who was manufacturing the plastic injection molds with, and you have to consider weight of the component, next weight of the runner, gate area respectively, and 15% reduction. This should be considered. This is the important key factors should be considered while you are designing the shoot capacity. After that, adding the values and everything, the actual shoot capacity will become in grams. Once it is over, then you go for the plasterizing capacity. What is the plasterizing capacity? Just nothing but in concrete. This is the total area content thermal cavity of the polystyrene. It is in calories per gram and total heat content. So after this, adding this your mold equation, you get kg per hour. So once it the design cavity and insert core plays very important role. For insert core and design cavity, this is the formula. Maybe this formula is there available in the sum. Okay. Maybe you are using the strength of material, sometimes you use this formula, the same formula using for the design of cavity and core inserts also. Okay. Once you find out the TA nothing but the minimum wall thickness of insert, and P is the maximum cavity pressure, kg per centimeter square. Once this calculation goes, then you come to know what is the cavity pressure, megapascal. Before it is kg per centimeter square. After that, you have to convert into the megapascal. Once it is completed the design cavity in 4 inserts, then you have to go for the solidifying the time. This is a very important role. Solidifying time, nothing but just like you're curing your cement. It's as simple as that. Solidifying means nothing but cooling your components. So what are the equations required for the sulfide time? This is the equation. Once you know the sulfide time in second, density of the plastic material used in gram per centimeter and the total heat content. So once you add all these equations and the formula and values, then you'll get the average temperature of the material, and then you'll take the temperature of mold and taking the average of this mold is will come to 35 degrees Celsius approximately. Once the solidified time is over, then you go for the cycle time. What is the cycle time estimation? Is it necessary in your project or maybe in a new product development? Yes, this is plays very important role. This cycle time depends, cycle time estimation depends on your injection time. See, this is the injection time. Okay, this is in seconds. Sulfide times in seconds. Mold opening and closing times are also in seconds. Okay, and this is the formula used and injection time is also in seconds. Therefore, the approximate injection times will be seconds. See, once the product is lived inside the between the top and bottom core, the time will be maybe in the 6 seconds. After 6 seconds, the product should be come out. If it not come out, it will be sticking in the bottom and the top bottoms. Then after consideration of cycle time, then you go for the mold cooling calculation. This is the mold cooling. What if the air should be there, water should be there per hour, how much water should be supplied inside this water, right, per hour. This is the equation using for this, and this is the total shoot weight in grams only. It is not in kg or something. It is almost in the grams because it is a plastic material. Okay, and numbers of shoots per hour is nothing but a value. Once you consider all this, then you go for the 3D modeling. See, once all the parameters is over, then you have to find out whether its core is perfectly not or not, dimensions, accuracy or not. Everything should be considered, and this is the fixed off moving part. Then this is a moving off of the tool. This will be done in the CATIM. Okay, and this is the assembly of the top and bottom cavities. Top bottom locating the ring, top plate, cavity plate, core back plate, spacer block, bottom plate, push back pin, and this is the electrode guide pillar and electrode plate and electrode plate. This are the plates. This is the bottom one. This is the top one. Once it's finished, when you see in the explode option is there. When you explode it, this is a real project. Real components will be appear like this. Okay. After that, the final splitting will be there. See, this is the bottom, this is the top, middle. So many components are there. Middle. This is your plastic injection mold product. This is your product, right? You can see it clearly. See, it is nothing but a die, man. This is the bottom die. This is the top die, bottom and top. This thing, right? When expert in the tool will be seen in this manner. Okay. Once this is over, then you go for the cost estimation. The first for a cost estimation, consider the raw material cost. Okay, tool design charges, machining cost, heat treatment cost, cost of the brought out and standard risk factors, and plus you have to take the profit also. After this is over, then you have to go for the characteristic metal ST42. What is the ST42 metal characteristics? Density of material, raw material size, volume of the material, mass of the material. Density into volume is equal to kg. That is the mass of the material. After the calculation of this total tool cost, then you go for the tool manufacturing and assembly and trial. Trial and error of the tool. For trial, the tool manufacturing, assembly, trial, there are three important things. One is the process planning should be there properly. Next is electrode planning should be there. Heat treatment for the specific part and manufacturing. The last parts will come to the manufacturing. See, once you finish all the four processes, this is the exact tools you are looking out here. This is the fixed off. This is the going off. You can see the tool here, right? This is the insert, this is core, this is the cavity where the runner should be inside center of this, right? Then after that, this is the assembly. Bottom and top is assembled together. This is assembled view of the tool. This is moving off, fixed off. They are separated. In the right side picture, we are assembled, right? What I was seeing in the CAD picture. Here, this is the tool we are given for the XYZ client for the manufacturing ticket issuing machine, right? So this is over now.
Yes, sir.
Yeah, Rashid. Now it is over. Do you have any queries, questions?
So, students, if you have any queries and questions, please post in the chat box. So, and you can answer that.
Hello. So can I ask one question? Hello, sir.
Yes, sir. Yes, sir. Tell me.
Ask one question.
Pardon, sir. Hello.
Ask one question.
Yeah.
Whether you understand this tool,
Yes, sir. Yes, sir.
Understand the tool? How the tool will be manufactured?
Yes, sir.
Hello.
Hello.
Yes, sir. Yes, sir. Yes, sir. Go ahead, sir.
Yeah, Rashid, any queries, any questions?
Now, students may ask the question after you were finishing the talk, sir. I also.
Okay. Hello.
Sir, I
Hello.
think some of them they have put in the chat box. You can see over there, sir. Naveen, sir.
What about the 3D printing? As it is quite simple. Sir, someone has asked about the 3D printing. See, 3D printing is an entirely different concept and different technology, whereas the tooling is different concept and different technology. Don't mix up both the things. 3D is different and the tooling is different. This is not a simple way. This is a difficult thing. The 3D printing, you have to draw the 2D and 3D drawing also. You have to select the plastic materials. Okay, but in 3D printing, maybe within a 1 hour you can see the prototype. Okay, but manufacturing is not like that. It take another maybe in the 7 days, 15 days like that. That's it.
Sure.
Any queries, man?
So students, if you have any queries about the topic or other topics too, you can ask in the chat box. Even faculty members can also ask the questions.
Hope students are not understand the how the tool is manufacturing. I think.
No, sir.
Plus,
We have got the idea.
you got an idea, right? So when you
Yes, sir.
take any new product, what are the challenges we are facing there? So that's
Ah,
the reason take one case study, shown that what are the tools are using, what are the calculations should I consider being an engineer, right?
yes, sir.
Will sir, any questions
Not from my side, sir. Nothing.
about your students?
Yeah. It's open to all now, sir. Anybody can ask. No problem.
Okay.
Even faculties also.
What other softwares are used in this process? We are using only CATI and AutoCAD, and another is FEA, means finite element analysis, ANSYS software. Only two softwares are used here. Someone answer what other softwares are used in this process? Only two softwares. One is CATI, another is ANSYS software. Can you tell briefly about FEA, please? Say FEA is like a vast thing. I can't explain in a few seconds. FEA is finite element analysis there, right? When you produce any component, you should go for analysis. Analysis depends on how temperature should be maintained. What is the temperature is impacting on that material? Someone is sent, sir, how is the mold preparation important in the industries, and what are the industries using the molds at present? See, it depends on the requirement. Kartik Shetty has questioned how is the mold preparation important in the industries, and what are the industries using the molds at present? See, molds are different for your different products. Okay. Another one, will the tool be designed under the simulation software such as ANSYS? Yes, it can be done in the ANSYS, man. Can I ask one question? Vilas sir?
Yes, sir. Tell me, sir.
So, whether the student can able understand my concept, like what is the tool, how the tool is manufactured in the industry?
Sir, overall, this thing they have got the information, I think, sir, because they have studied already MP1, MP2, and all.
Okay.
I think they understood with this.
Maybe some of the formulas are not used in the MP1, MP2, it seems.
No. Those formulas, they are practical one. No? You are going to use in your industries. But in our this thing, in our subjects, we are not using all those things.
Okay.
And basic things about density and all, they are knowing. They are knowing about that.
Okay. What can you suggest to prepare project on the topic of the final year? See, I can suggest one thing is when you do any final year project, be an online project. And online project means take a real project and take advantages of those projects and understand the concept of the project and develop it. Don't go in the market, purchase the project and come back. Please go to visit the industry, okay, select a real project, okay, and take this real project, understand the concept, why I have taken this project, what are the challenges I should face. Then only the project will be final. See, whatever the final year project you are going to do, that is value added for your resume. In weight formula, meaning of X. It is not X, man, it is into. X means I don't want to disclose some values in that because this is the case study I have taken. This is my case study because the client given some values. I can't show it off to you also because some confidential formulas will be there and values are there. I can't show it outside. Sorry. How do you determine the factor of safety for a different product? See, factor of safety depends on the product, how you are taking that one, how you should manufacture, whether which tools are taking, what type of metal you are using, what type of machines are using. Factor of safety depends on the machines, tools, and the products. So different client requirement, different factor of safety should be taken. Usually in our industry, we are taking the factor of safety maybe 2 or 3, not more than that.
Hello, hello, hello,
Hello.
Naveen. Hello,
I can hear you.
are you hearing me?
Yes, sir, I can hear you.
Hello.
What
Yeah.
is
No,
what is not able?
actually, students, no, they doesn't have any the practical experience of plastic injection molding process. Only theoretically they read in the book. But the thing is, the students should visit some factory to see the actual the plastic injection molding process as well as manufacturing. That is most important. Okay. Anyway, if everything will all right, okay, we'll send some students. Otherwise, those students are interested to your factory, okay, to see this actual process of injection molding. Okay,
Yes, sir.
please go ahead, sir.
I want to add one thing, like, sir, whatever said is true, sir. So theory is entirely different, practical is entirely different. Okay, when we are in the student, even we doesn't know what is the plastic injection mold, right? When you come to the field, we learn all those things, right? For this, we should have the one industry should be there. One thing. Second, you should understand the basic concept. I'm not saying that you should understand each and everything. You should understand the basic concept. And parallelly, industry and academics, education should interact with each other. They have to send for the like training for the any industries, so the project carried out. So 99% what I've seen in the college, they go and do in the outside and buy the project and come back. This is the scenario is happening now. But tooling plays very important role in the today's generation, sir. Today's scenario, plastic plays a very important role.
Yes, you're right.
So
Naveen. Okay.
last
Please
two
go ahead.
questions
Please go ahead.
in the chat
Hello.
box. So there are
Sorry?
last two questions which are unanswered in the chat box.
I said no, factor of safety depends on the metal, machines, and tools.
South Khan and Amit, yes, two of them have asked.
Sorry, sir, I didn't see that. Sir, since you said the theory is different from what we use in the industry, we could not better to learn the 4 form directly and learn the better. See, I can't say that so many times given the letter for the VT also change the syllabus according to the industry scenario, right? They're not doing that one thing. The second thing, they're not upgrading the topics. Keeping the same old topic for another 5 years, 10 years, it should not be happen. See, your syllabus should be changed like 2 years, 3 years once, okay? And Amit, yes, is there any safety measures should be taken while manufacturing the product? Yeah, safety measures should be taken like how the pressure should be taken. If you keep the more pressure, the mold will 100% chances are that it will be broken down, mold. Last one, what are the courses do you suggest to do online before the guide? See, I've seen a lot of students who are doing it online only for the certificate, man. I don't entertain those certificate. Please go through courses online, whether it is online or offline, but understand the concept. This plays very important role. Certificate doesn't play in your life, okay? Your knowledge, your thinking capacity plays very important role in your life, not your certificate. Clear?